Okay, with implicit differentiation is when you have an equation that doesn't have y equals in it. Like this one right here. Okay? You don't have y equals, you have a circle there where y is part of the function itself. And it's much easier to solve it implicitly than try to solve for y. Some equations you can't even solve for y. So we'll start off with this one implicitly. And I'll show all the steps first, and then after this example, I'll just go ahead and start taking derivatives. So we'll start always using the chain rule. Okay. So we have x squared here. So we'll have to find the derivative of x squared with respect to x, and multiply it times the inside function, which is x itself, with respect to itself. Okay. Plus the derivative of y squared with respect to x as well, times the derivative of the inside, dy dx. And the derivative of a constant with respect to x. Okay, so just finishing it out, we remember this always equals 1, derivative of x with respect to itself equals 1, and taking the derivative of this part is just simply 2x times 1, and we got 2y times dy dx equals 0. Keeping in mind, this is what we're trying to solve for right there, dy over dx. And so I'm just going to put all the dy dx terms on one side and put all the other terms on the other. Okay, on this way, 2y. Okay, we can divide by 2. The 2's go away. And then we could also divide by y. Actually, we'll divide by y as well. Dy dx equals negative x over y. And that's your answer. Now we can plug in the values that were given right there, and leaves us with negative 4 over 3. Okay, this is the same exact format, except you have a hyperbola instead of a circle. You have a minus sign right there. Okay. And so going straight into it without writing the denotation first, we'll just take the derivative of x squared, which is 2x minus 2y. Well, I'm going to back up so I can show you exactly what's going on. It's 2x dx dx minus 2y dy dx. 0. This portion right here you'll never have to write again because it equals 1. If you feel more comfortable putting it down, go ahead. Otherwise, just leave it out. And do the same thing. We're going to put all the dy dx terms on one side, and then finish the problem. Okay, divide by 2y, negative 2y. And we got x over y, plugging in the numbers. You're left with 5 over 3. Doesn't matter where the negative goes, top, bottom, middle, doesn't matter. This problem requires the product rule right there. X y prime times y. Just for this portion right there. Okay. When it's all said and done, we get that right there. And right here you can already start plugging in the numbers. Okay, just plug the numbers right in. And plugging them in leaves you with that right there. And next step is combining these guys. You need dy over dx, but you have 2 of them. How do you combine that so that you end up with 1 on one side? We'll what you do is you keep all this on the same side and move the 3 over to the other side.
Okay.
And you end up with that. Now you can factor dy dx from both sides. First I'm going to shrink it. And so factor out the dy dx, undistribute it, leave it with x here, plus 1. Okay, one thing left to do now is isolate dy dx. And there's your answer. Okay, for this problem, again, using the product rule, okay, and it translates to first derivative of the second plus the derivative of the first times the second. Okay, all this is just for that one part right there. Okay, and after you do it, I'm going to take the derivative of the whole thing. You end up with that right there. Now the problem here is, well, after you plug in the numbers, 2 for x, 3 for y, you end up with this right here. After you take the derivative, plug in numbers, make sure you combine all like terms on one side and put everything else on the other side. For instance, you need these two combined, and you need to move this to the other side. Okay. So we'll subtract the 3, leaving you with this right here, and then just go ahead and combine these. 2 dxy over dt plus another dy dx. I don't know why I said dt. Anyway, leave it with 3. If you don't understand how I got from here to here, it's the same thing as adding 2x plus x gives you 3x. But we're not dealing with x's, we're dealing with dy dx's. And then last but not least, divide by 3 to both sides. And you get 1. And that's your answer, -1. For this one, you have a combination of 2 product rules. Okay, and so taking the product rule of each individual, you end up with this for this portion. Okay, all of this for that one portion, and then this for the blue portion. Okay. And now just plug in this, and after cleaning it up a little bit, you end up finally with this right here. Now we're going to combine all the like terms again on one side. Bring this over, bring that over. Okay. So we're going to subtract 2, subtract 1, and then these two added together gives you 3 of them. Okay. And those two together give you that right there. Finally, you can just divide by 3 to both sides. And that's your answer. Okay, we have another combination here of, we got right there the product rule. But first you have to take the chain rule using the radical. So we'll first rename it to this right there. Okay, when you use the chain rule here, go ahead and start solving it. Okay, times the derivative of the inside, which right there you use the product rule, giving you that right there, and finally ending up with this. Okay, keep in mind all this goes on the bottom to join the 2. Okay, so that leaves you with this right here. I'm just going to change that on the bottom. Instead of writing xy to the 1/2, we're going to write the square root of x bar. It means the same thing. Okay. So plugging in numbers, you end up with this right here. However, I'm going to change again this portion. 2 times 2 is 4. The square root of 4 is 2. Okay? And we can change this whole bottom portion itself to 1 over 4. Okay. All that's left to do is distribute the 1/4 to both. And you end up with that. Keeping in mind that reduces to 1/2. And I'm just going to go ahead and replace it so that we have this right here. And moving this to the other side, you get minus 1/2. Okay, and then you got to combine these two. 1 dy dx plus 1/2 of dy dx equals 3/2 dy dx. And lastly, just get rid of 2/3, 3/2 by multiplying by each side by 2/3. Leaving you with your final answer. Okay, the chain rule again. Bring that 2 out to the front times the inside times the derivative of the inside. So derivative of x is 1, derivative of y, dy dx. And go ahead and plug in numbers. And you should end up with that right there, and then cleaning it up leaves you with this right here. And all I did was just combine those two for this. Finally, you can get rid of the 1 after you clean it up, and then distribute the 2. And you end up with that right there, and then we can just bring the 2 over to the other side, subtracting it. Okay, and then combining these, you got 2 of these plus another one, it gives you 3. dy dx equals -2. And now you can probably just divide that 3, and you have your answer of -2/3. Okay, another one not so bad. You take a derivative of the first portion, derivative of the second portion. And just plug in the numbers so that you have that, and after cleaning it up, you end up with this right here. Now, be careful not to turn that into thinking that the answer is 0. The fact that this part disappears tells you that dy dx doesn't even exist, making it undefined. And after you actually do the algebra by moving the 4 over, okay, the algebra will actually show you that it is indeed undefined and not equal to 0. So be careful. Undefined or does not exist. If you had a 0 on top, dy dx equals 0. On the bottom, undefined. And we have the lovely chain rule again. Okay. Derivative sign is cosine. The inside times the derivative of the inside. Using the product rule to do that, you end up with this right here. And then keep in mind, you want to separate all dy dx terms on one side and put everything else on the other. So you'll have to distribute cosine x to both sides so that you end up with this. And now what you want to do is take this whole thing, bring it to the other side. So that you have that right there. And that right there, and you want this by itself, so you can now divide out the x, cosine xy. Okay, cosine, all this right here cancels, leaving you with y